Hi, algebra folks. We're going to do some multi-step equations in this video. If you're with me in class, at least currently, at the time of this video, this is the packet for topic 3. In the future, who knows, maybe we'll have a different packet, but as of the time of this video, this is the packet. So doing multi-step equations, I'm going to jump to page 72. All right, so here I'm on page 72. So they call this solving an equation with separated unknowns. The unknowns, by the way, that would be your variables. So let me get a couple things here. So we're on page 72 if you're following along in your packet. And when they say separated unknowns, the unknowns would be the variables. What we don't know. You know, X is very common, or A or whatever. Those are the things we don't know. We don't know the value of the variables, but in this case, we want to know. We don't know, but we do care. So I'm going to go down to the bottom of this page, and you can, of course, read through, but just notice what they're doing here on the example at the bottom of this page where they've solved one for us, and notice what they've got here. We have 2x for this given equation here. 2x plus 3x equals 25. And notice the first thing they have written down, 5x. Where does the 5x come from? Well, that would just be the left side, 2x plus 3x. So what they're doing here is they are simplifying. Simplify first if you can. Up to this point, most of the equations you've probably seen, you can't do any simplifying. But here I go, yeah, 2x plus 3x. That's 5x. It's 2 xylophones and 3 xylophones. That's 5 xylophones. Why don't we just call it 5 xylophones? And then they continue solving it from there. So let's take one that they haven't done for us. So here, if I physically separate the left side from the right side, and you can even pretend, remember, don't worry about the side that doesn't have the variable. Don't worry about the 32. But if you just look at the left side and go, hey, 3y and 5y, by itself, that's 8y. It's 3 yo-yos and 5 yo-yos. That's 8 yo-yos. So I can simplify the left. Notice I'm not canceling anything. I'm not canceling the 3. I'm not canceling the 5. I'm combining like terms. But now that's as much as I can do with the left side, 3y plus 8y. So now I need to bring back the right side and say, okay, well, now it's 8y equals 32. I can't simplify 8y anymore. Now I'm going to cancel. So that's multiplication by 8. I will divide by 8 to cancel multiplication by 8. 8 divided by 8 would be positive 1. That would be positive 1y. Divide over here by 8. That's going to give us y equals, I believe that'll be a 4. Still important to do the check step. So let's do that here. And it's still important to do the original equation. Just in case, if I have a mistake in 8y, maybe I made a mistake. Maybe it should have been 15y. Maybe I should have multiplied 3 times 5 or something. So if I check the original equation, 3y plus 5y, is that equal to 32? And if I substitute in here my value for y of 4, so I'll put it both places there. So this will become 3 times 4 plus 5 times 4. And is that equal to 32? So now remember, I don't have to cancel anything. I'm just checking. At this point, I don't have to cancel anything. I'm just checking. It's all numbers and operations. So follow your order of operations. On the left side, we multiply before we add, generally. So 3 times 4 would be 12. That addition outside parentheses or grouping symbols, the addition is going to go last. 5 times 4 is 20. Is 20 plus 12 equal to 32? Yeah, some of you are already saying, yeah, that works, but I like to write it out as 32 equals 32. So this is a good answer. Y equals 4 is a good answer there. Okay. I'm going to go to the next page here. So you can try the next one if you want to there, but let's see if we can find a good example on page 73. I think I'll do a couple towards the bottom here. I think I'll do, for number 6, I'm going to do the last one in that column, and then I'll do Yeah, I'll do the first and the last in number 6, the first row and the last row there. So, all right, looking at the first problem in row 6 here. Again, if you look at the left side and the right side, the left side it's 4 apples, take away 2 apples. We can combine those. That's just going to be 2 apples. The right side, oh my gosh, the right side can simplify also. That's just 7 plus 13. That's just 20. So notice I haven't canceled anything yet. Again, I'm not canceling yet. I will, but I haven't needed to cancel yet. I'm just simplifying. I'm simplifying first. I'm just doing what I can do. Now 2 apples by itself, I can't do anything with 2 apples. On the left side, $20 by itself, I can't do anything. So now I'll cancel. Now I'll say, all right, let's get rid of that 2. It's 2 times A, so let's divide by 2. That'll be 1A, positive 1A. Divide by 2 there, and we're going to get, that'll be A equals 10. Still important to check. I'll just kind of quickly do the check step here. It'd be 4 times 10 minus 2 times 10. Does that equal 7 plus 13? And you can work through all that. I recommend it, but what you're going to find, this will be 40 minus 20. 7 plus 13 we already know is 20, and this checks out. 40 minus 20 equals 20. But remember, you should still be doing the check step. All right, so now let's do the last one in that row. Switch up here. So 2y minus y plus 2 equals 7. So again, physically separate left side from right side, and look in, if I ignore the 7 on the right side, the left side, remember, you can sneak in a 1 here. 2 yo-yos minus 1 yo-yo plus 2. I go, oh, this can simplify. That's just going to be 1y. 2 minus 1 is 1. 2 yo-yos minus 1 yo-yo is 1 yo-yo. 2y minus 1y is 1y. Now the plus 2, you might be tempted to say, oh, should we do the 2 plus the, what is it, a 7? No. The 2 and the 7 are on opposite sides of the equal sign. They do not combine as they are. The left side of the equal sign, it's a yo-yo and $2. The right side is $7. The 2 and the 7 don't combine as they are because they're on opposite sides. But what I can do now is I can cancel that 2. I can subtract it to cancel the addition, and I can balance my equation. And that would give me then 1y equals 5. And for those of you, if you want to work smarter instead of harder, you could be like, well, 1y is the same as y. 1 yo-yo is a yo-yo. So we're essentially done. Y equals 5. Some students still like to just follow through and be like, hey, let's divide by 1 to cancel the 1. I go, all right, nothing's going to change. You'll still get the 5. Y equals 5. Okay. And again, don't forget, we should be checking that. We should be doing 2 times 5 minus 5 plus 2 and check if that's 7 to do that check step there. Okay. I'm going to jump to another section here. Oh, but first, before I do, so just to emphasize, number 6, the first problem we did, the 7 and the 13 were on the same side. So we said, yeah, go ahead, do 7 plus 13. It says 7 plus 13. But the last problem in that row, the 2 and the 7, not on the same side. So we don't do like, oh, 2 plus 7 is 9. I go, no, actually I'm gonna cancel the 2 by subtracting. I'm gonna do 7 minus 2. So just notice that. If they're on the same side and you can combine them, go ahead. If they're not on the same side, then you got to cancel. All right, now we'll jump to the next page. All right, so just the very next page in the packet, I'm on page 74 now. When the terms on both sides of an equation, terms here, they mean the variable terms. So what if the variable is on the left side of the equal sign, but it's also on the right side? Again, you can read through their examples. If we check out what they did, the first one that they worked through for us here, notice what they're doing. I would show the work a little bit differently, and I'll do that, but they don't combine the 4x and the 3x to be like, hey, isn't that 7x? 4 xylophones and 3 xylophones, isn't that 7 xylophones? But they end up subtracting them. And if it's not clear to you, I'll explain here in a moment. But they get x equals 6. We can still check that. We can say is 4 times 6 equal to 3 times 6 plus 6. We can check their work there. But I'm just going to get into the next problem here. So again, good habit, separate left side from right side. The left side by itself doesn't simplify. 5 yo-yos by itself, that's just 5 yo-yos, okay. What about the right side? Can I simplify? By itself, 2y plus 9 is not 11y. It's 2 yo-yos and 2 yo-yos and $9. Remember, those are not like terms. So neither side simplifies, all right? So just be aware of that. Neither side simplifies, but check for that. So this is where, for me, the first thing to do at this point then is to say, get your variable on only one side. Get x on only one side, or excuse me, this is y. Get y on only one side. And it's your choice. You can keep y on the left, or you can keep it on the right. As long as you do things correctly, you should be able to get the same result. But I'm just gonna, for this problem, I guess, sorry, I'm just gonna say, you know what? I've got the yo-yos and the dollars on the right. The left is only yo-yos. Let's just put all the yo-yos on the left and just the dollars on the right. So the trick is you can add or subtract the variable. You can, I'll write it out here, you can add or subtract the variable. As long as you do it on both sides, you're fine, as long as you balance. So I go, hey, the yo-yo's on the right side. I don't want the yo-yo's on the right side. All right, well, there's 2 of them. Let's take away 2 yo-yo's. No more yo-yo's on the right side. But now I got to balance. Now I got to subtract 2y, take away 2 yo-yo's on the other side. So that's the trick that you might not realize, to be like, well, we can do that? Yeah. And now on the left, 5 yo-yos, take away 2 yo-yos would be 3 yo-yos. The right side, I had 2 yo-yos and $9. We took away 2 yo-yos. Now I've just got the positive 9. And from there, if you can get that, I go, well, now it's pretty simple. Now I just got to divide by that 3. Divide by the 3. And then we cancel the 3 there, so we get positive 1y. And then 9 divided by 3 on the other side is coincidentally a 3. I'm going to check this. If we check, so let's see what color I'll go. We'll go orange here. So doing the check step for this problem here, I'll try to be quick. You should always be doing the check step though. So it'd be 5y equals 2y plus 9. That was the original equation. If we put that 3 in, it would say, 5 times 3 equals 2 times 3 plus 9. Is that true? I don't have to cancel anything at this point. I'm just checking. I'm replacing the variable with its value, what I think is its value, and now I'm just doing the operations. 5 times 3 is 15 over here. That's a 1. 15. 2 times 3 would be 6 plus 9. And yeah, I mean, for space, well, I guess I can squeeze it in. 15 equals 15. That works. So y equals 3 is a good answer. I think just for time, I'm going to scoot to the next page, but you can try the next example if you haven't yet. And let's see. Let me pause here and see if I can find a good one. I'm going to skip down to the bottom of page 75 and maybe do a couple of problems here, or at least get started on them. So I'm going to go with row 7, excuse me, the last row, number 7. I'm going to start with the first one here. So again, just thinking things through. Left side by itself does not simplify. 5y plus 9 doesn't simplify on its own. The right side by itself, negative 2y plus 30. Those are not like terms. It's yo-yos and dollars, or however you remember that. So we cannot simplify. But look for that. We cannot simplify. Sometimes we can. Earlier in this video, we had problems where we were able to simplify before canceling. So now we want the variable on only one side. Get the variable on only one side. And it's up to you if you want to keep it on the left or keep it on the right. This one, I'm going to do 2 ways. I'm going to do one example where I keep it on the left, and then I'll do the same problem, but where we keep it on the right. And I'll show you, as long as you do things correctly, you should get the same result. So if we keep it on the left, keep y on the left, that means I want to get rid of it on the right. Well, on the right, I owe 2 yo-yos, and I go, I want to, no talk of yo-yos on the right side. So all right, if I give you 2 yo-yos, pay your weird yo-yo debt, and no more yo-yos on the right. but I got to balance. I got to add 2y on the other side. Again, you can add or subtract the variable. I would end up here with 5 yo-yos, $9, and 2 yo-yos. That's going to be 7 yo-yos and $9. And the right side, it'll just be the positive 30. Positive 30. If it was minus, that'd be a negative 30. Okay. And from here, if you've practiced two-step equations, I'm going to try to go quickly at this point, but it's pretty quick from here. Subtract the 9 to cancel that. And you'd get 7y equals 21, divide by 7, and you get y equals 3. Oops, because that cancels, y equals 3. Now you should still check, go back to the original, is 5 times the y value of 3 plus 9, is that equal to negative 2 times the y value of 3 plus 30? And you should be checking that. This would be 15 plus 9, that'd be 24. This would be a negative 6 plus 30 would be a 24. Yeah, it checks out. It says 24 equals 24. So y equals 3 is a good solution. But now what I'm going to do is I'm going to do the exact same problem, but I'm going to keep y on the right side. And I want to show you that we're still going to get 3 as our value. It's just going to say 3 equals y instead of y equals 3. So let me rewrite the equation here. It was 5y plus 9 equals negative 2y plus 30. So if I keep, this time, if I keep y on the right, because it's my choice, I still can't simplify either side, but if I just say, you know what, I just want to keep it on the right, well, that means I have to get rid of 5 yo-yos on the left then. So I can take away the 5 yo-yos, no more yo-yos over there, but I got to balance. So I'm left here now with a positive 9 on the left. And over here I owe 2 yo-yos plus 30. We're trying to take away 5 yo-yos. You can do negative 2 minus 5. That'd give you negative 7. With the y's, this would be negative 7y plus 30. And again, if you're good with your two-step equations at this point, you might be able to go kind of quickly. Y is only on one side now. Subtract the 30. We get negative 21 equals negative 7y, and I'm not going to add 7, I'm not going to divide by 7, I'm going to divide by a negative 7. Negative 7 divided by negative 7, and wouldn't you know it there, negative 21 divided by negative 7 gives us a positive 3. It's just that I got 3 equals y versus y equals 3, but it's the same value, and I don't care in the end, do you say y equals 3 or 3 equals y? All right, so yeah, that's with the variable on both sides. You can add or subtract the variable. We're going to do one more section here. So I'm jumping ahead a few pages now to page 78. And actually, this page is just examples, so you can find that if you've got the packet. You could read through their examples, see what they do. But I'm going to jump to the next page, so page 79 here. And I think I'll just do maybe the first row. You can see what they did in the first column for number 1. But again, just kind of some of the ideas is check to see if you can simplify. If I look at the left side of this equation, I go, oh, that's 3 baskets. I can distribute the 3. So I can simplify here that 3 times n plus 2. So before I try to cancel, I can distribute. I can do 3 times n plus 3 times 2. Okay, what's on the right side is just going to hang out and kind of wait for us. So that 27 is just going to say, hey, let me know when you're done simplifying over there, when you're ready for me, when you want to start canceling some things. So 3n we just write as 3n. 3 times 2 is 6. Now that's as much simplifying as I can do on the left. It's 3 napkins and $6. It's not 9n, remember, even though 3 plus 6 is 9. I go, it's napkins and dollars, not like terms. But now I can start canceling. Can't simplify anymore, but now I can start canceling. So if I take away the 6, and then I will end up dividing by 3 here. We'll get 3n equals 21, and divide by 3. And so we'll get n equals 7. I'll do the check step here. So if we check that, Now remember, check the original. So 3 times n plus 2 equals 27, but we think n is 7. So 3 times, remember I like to put the given parentheses as big, and then when I put parentheses around n for the 7, I make that smaller. And now here I don't need to distribute because I can do what's in the parentheses. Back here, n plus 2, I can't perform n plus 2. But now that it's 7 plus 2, I don't need to distribute. I can do 7 plus 2, that's 9. So I get 3 times 9 equals 27. You bet. 3 times 9, yep, 27 equals 27. So 7 was a good number. 7's a good value because when using that, my equation says 27 equals 27. I'm going to do one more example here. Towards the bottom, I'll do the bottom right here. This last one here. So looking left side and right side. Again, I notice that I can simplify. Actually, on both sides. This time we can simplify both sides. Look at that. On the left side, I can do 7 times a, and then I'm going to chop slash that, plus negative 1. 7 times a plus 7 times negative 1. And that'll equal on the right side 6 times a plus 6 times 1. Oops, 6 times 1, like that. I can simplify this a little bit more here. 7 times a is just 7a. 7 times negative 1 is a negative 7. 6 times a is 6a, and 6 times 1 is 6. But now I'm at that point. On the left side, 7a plus negative 7, or 7a minus 7, doesn't simplify. 7 apples, and we're trying to take away $7. Right side, 6 apples and $6 doesn't simplify. But now I'm at a point where the variable's on both sides. I go, oh no. So at this point I say get the variable on only one side. And it's up to you, and I'll talk a little bit about if there's a smarter way to do this. I think, and I'll explain here in a moment, I think it's going to be smarter to keep the variable on the left, meaning get rid of the 6a on the right. Remember, you can add or subtract the variable. There's 6 apples over there. If I take away 6 apples, no more apples. I got a balance though. I got to take away 6 apples over there. And notice what that gives me here. 7a minus 6a is just 1a. I still got the plus negative 7. It's still equal. That's a positive 6 over here. I can add 7 on both sides. I owe $7, so I'll give you $7. Balance that. And then that's going to be 1a equals 13. And again, some of you are going to say, let's divide by 1. But some of you are going to be like, wait, 1a is a. 1 apple is an apple. So it's just a equals 13. Okay. Don't forget to check. I'll do the check step real quick here. But then I'm going to give you a piece of advice going back to this part right here. If you had kept the variable on the left side, or excuse me, kept it on the right instead of the left. But let's check real quick. So this would be 7 times in the parentheses 13 minus 1. And that's supposed to be equal to 6 times in the parentheses 13 plus 1. Is that true? So here, remember, I have the numbers. I'm not canceling now. I can just do the operations. So work inside the parentheses. 13 minus 1 is 12. Here, 13 plus 1 is 14. Is 7 times 12 the same as 6 times 14? This one I know is 84. This one I'm going to grab the calculator. 6 times 14. I don't remember that one. But it's 84. So there you go. Good. All right. Awesome. So I like this. Box in my answer. That's a good answer. Okay. So one more note on this, and then we'll wrap the video up. If you had decided, let's see if I can squeeze in, or kind of, I don't know, transport here. If we go from here, and I'll just rewrite it. If you were of the mind that you said, you know what, I want to keep the variable on the right, that's okay. But what you would do if you keep it on the right, it means you're canceling it on the left. So you'd have to take away 7 apples so that you don't have any more apples on the left. And as long as you balance, you're good. But notice what happens here then is we'd have a negative 7 on the left, and 6 apples take away 7 apples, so you're going to owe an apple. That's going to be negative 1a. So it's not wrong to do this. I'm not going to finish it from here. You could, if you keep going, you should still get a equals 13. But just notice right here, the 1a is already a. So if you're trying to work smarter instead of harder, if you recognize that, go, hey, I could either do 7a minus 6a, get 1a, that's just a. Or I could do 6a minus 7a, get negative 1a, then I'm going to have to deal with that negative. I would do it this way because it's going to be quicker, but both ways work. Okay. Last thing I'm going to say is just remind you that you can check your answers. If you've got this packet, you've got the answers. They're back on page 193, or that's where they start. So page 193 here. This is where the answer key starts for the packet. I don't think that's any pages that we did, but I encourage you, if you've got the packet, try it out, read their examples, see their explanations, try their practice problems, and then check your answers, and then let your teacher know if you need help. So hope that video helped. Thanks for watching.